Here's a quick look at our agenda for today. We're going to cover the anatomy of the explosion, the static fire procedure itself, diagnosing the technical root causes, the resulting threats to commercial satellites, and finally, the cascading delays to the Artemis missions. Section 1, Anatomy of the Explosion, May 28, 2026, at Launch Complex 36.
Okay, so zooming in on Cape Canaveral at approximately 9 p.m. Eastern Time, a towering 320-foot heavy lift rocket fully loaded with highly volatile cryogenic propellants suddenly detonated. Now, thankfully, all personnel had safely evacuated to bunkers way before fueling began, so there were absolutely zero injuries. But the hardware? Well, that tells a pretty grim story. Jeff Bezos summed it up by calling it a very rough day, though he did affirm the company's sheer determination to rebuild whatever it takes. The sheer scale of the pad damage here is staggering. I mean, the overpressure shockwave was so incredibly intense that it completely toppled the right-hand lightning protection tower, and that is a massive, highly reinforced steel structure. Worse yet, burning liquid oxygen and methane just flooded straight into the subterranean conduits and cableways. From a historical engineering standpoint, this is eerily similar to the 2016 SpaceX Amos 6 anomaly, which, you might remember, took well over a year to excavate and rebuild. Blue Origin isn't just missing a rocket today, they are completely missing the highly specialized, complex foundation required to launch one.
Section 2, the static fire procedure, a critical pre-launch rehearsal. So, to figure out what went wrong, we've got to understand what they were actually trying to do. A static fire test is basically a full dress rehearsal. The rocket operates exactly as it would on launch day, igniting its engines at full thrust, but it remains firmly tethered to the pad. It's the ultimate stress test for the propulsion system, designed to ensure everything is functioning flawlessly before they ever get the green light for actual liftoff.
This procedure follows a really strict sequential order. First, they securely tether the booster to the mount. Then they load it up with sub-zero liquid oxygen and methane. Finally, they ignite its 7 BE-4 engines. For this specific sequence, they were using a refurbished booster, designated Booster Number 3. This was supposed to be the final checkout before a massive commercial flight scheduled for just a week later. But instead of a controlled brief burn, the whole thing resulted in a rapid, catastrophic deflagration.
Section 3, diagnosing technical root causes, finding answers in the ashes. Now, this brings us to a huge problem. How do you actually pinpoint the root cause of a failure when your primary piece of physical evidence has been vaporized? We're talking about a blast so bright it lit up the night sky all the way up into South Carolina.
Well, because the physical hardware is just gone, the digital footprint becomes absolutely everything. Right now, investigators from Blue Origin, the Space Force, and NASA are meticulously combing through thousands of high-frequency telemetry data points. They're syncing that up with high-speed video frames recorded in the literal fractions of a millisecond before the blast. What they're looking for are sudden pressure drops, weird temperature spikes, or sensor cutouts that would indicate exactly where a fuel or oxidizer leak started, which was most likely somewhere near the engine nozzles or the manifold assembly.
And you know, history actually offers us a pretty chilling parallel here. Think back to the Apollo 6 upper stage in 1968, which suffered a fatal fuel line rupture due to resonant vibration. New Glenn likely experienced similar, incredibly complex structural harmonics. Think about it, igniting 7 massive BE-4 engines simultaneously while the vehicle is literally bolted down to the Earth generates ferociously violent, transient vibrations. Aerospace historians are already pointing out that these fierce vibrations likely ruptured a high-pressure methane manifold right at startup, dumping highly explosive fuel directly into the superheated ignition zone.
Moving on to Section 4, threats to commercial satellites, a disrupted market, and ticking clocks.
Zooming out from the launch pad itself, we really need to look at the immediate multi-billion-dollar business fallout. New Glenn's recent track record has been rocky, to say the least. Sure, the first 2 flights in 2025 were huge successes, but Flight 3 in April 2026, that had an upper stage anomaly that stranded a very expensive commercial satellite in the wrong orbit. And now, Flight 4 has resulted in total destruction before it even left the ground. This inconsistency, capped off by a grounded heavy-lift fleet, is creating a massive bottleneck for the entire commercial space industry.
1,618. That is the exact number of Project Kuiper satellites that Amazon is legally mandated by the FCC to launch by July 2026. And 48 of those exact satellites were sitting right on top of this exploded rocket.
Here's where the logistics become a total nightmare.
Launch Complex 36 is Blue Origin's only active orbital pad. Without it, Amazon's aggressive satellite rollout is entirely stalled. They are required to have half of their massive broadband constellation in orbit by that July deadline. Otherwise, they risk losing their spectrum allocation altogether. United Launch Alliance is totally bottlenecked right now with Department of Defense priorities, and Blue Origin's pad is literally rubble. So Amazon finds itself in extreme regulatory jeopardy as they try to compete head-to-head with SpaceX's Starlink.
And it's not just Amazon feeling the heat. Commercial partners like AST SpaceMobile are staring down crippling rollout delays. Remember, AST SpaceMobile just lost their Bluebird 7 satellite on New Glenn's previous botched flight. They were heavily relying on this rocket's massive payload capacity for future deployments. Because of this explosion, we saw instant volatility across the broader space stock market, with investors frantically looking for alternatives, like Rocket Lab's developing Neutron rocket to fill this massive void left by Blue Origin.
Section 5, Delays to Artemis Missions, the Lunar Ripple Effect. Let's zoom out to the absolute furthest extreme, the Moon. The stakes here include a $188 million contract that NASA awarded to Blue Origin to develop lunar terrain vehicles. And get this, that contract was granted just 2 days before the explosion. It was a huge vote of confidence from NASA for their decade-long plan to build a permanent moon base. The problem is, NASA relies heavily on Blue Origin's uncrewed Blue Moon Mark I cargo landers to deliver those critical rovers, and New Glenn is the designated launch vehicle for those landers. These uncrewed cargo drops are an absolute non-negotiable prerequisite. They have to deliver heavy surface infrastructure to the lunar South Pole before we can even think about sending human astronauts down there. So look at how this failure cascades directly down the Artemis timeline. The schedule was already super tight, right? Now the Blue Moon Pathfinder mission slated for late 2026 is grounded indefinitely. Because that gets pushed back, the Artemis 3 crewed orbital test in 2027 gets delayed, which means the grand vision of putting humans back on the lunar surface for Artemis 4 in 2028 is severely threatened. A single ruptured fuel line in Florida has literally altered the trajectory of human lunar exploration. As NASA Administrator Jared Isaacman recently pointed out, spaceflight is incredibly unforgiving, and developing new heavy lift capability is extraordinarily difficult. NASA purposefully built their Artemis contracts to rely on multiple commercial partners exactly for this reason, so a catastrophic failure from one company wouldn't just nuke the entire program. But the total loss of Launch Complex 36 is testing the absolute limits of that planned redundancy. Which leaves us with one final, incredibly provocative question. As the blast radius of this anomaly expands outward, are we witnessing a fundamental shift in the future of space exploration? I mean, if Blue Origin cannot rapidly rebuild that pad, the redundancy NASA was banking on vanishes. Will NASA be forced to rely exclusively on SpaceX's Starship to keep the lunar dream alive? It is a fascinating, high-stakes situation, and definitely one we'll be watching closely.